Okay, so today what we're going to be looking at is a logarithm. And so you can see my cute little image here of a log that's got some rhythm. So here's our logarithm. And so let's take a look at the warm-up. And so what we're looking at is a couple of questions that deal with some exponents. And we're trying to solve for y in each of the following equations for the first example. So in order to solve for y, notice that y is in your exponent. In order to actually solve for this, what I need to do is try to figure out an equivalent base so that I can actually compare exponents. So for example, if I had 2 to the exponent 3 equals 2 to the exponent y, then it's very obvious that the exponents must be equal to each other in order for the statement to be equal to each other. Since the bases are the same, the exponents must also be the same. And so what I'm going to try to do is rewrite the bases here, or the base on the left-hand side here, so that it's equivalent to the base that I have on the right-hand side. So if I rewrite 27, I can rewrite it as 3 to the exponent 3. And that'll give me an answer that's equivalent to 3 to the exponent y. And so again, since the bases are the same, then if the statement is true, then that also means that the exponents must be the same. So that tells me that 3 is equal to y. Okay, and I can check that very quickly by plugging it in here. If I do 3 to the exponent 3 on my calculator, 3 to the exponent 3, I get 27. So I know that that's correct. Okay, let's try the same thing for the next one. This one's a little bit more challenging since the value that I'm trying to rewrite here is a much larger number. So I'm trying to write it as 3 to some exponent. Now my goal is to try to figure out what that exponent would be to make 59,049 as the answer. So let's try a few different numbers. So I'll try 3 to the exponent 5. It's too small, so let's try 3 to the exponent 7. Still too small, so 3 to the exponent 10 maybe. And we get the right answer. So I'm going to rewrite this as 3 to the exponent 10. And again, since the bases are the same, then that means that the exponent part must also be the same. So y is equal to 10. Okay, in this course we're going to look at a different way of evaluating a statement like this so that you don't have to sit there and do trial and error each time to actually solve for the exponent. Okay, the second question just asks us to evaluate the following on your calculator. So we're just going to look at our calculator, and it looks like there's a new function that we're going to be using, and that function is called the logarithm. So I'm going to try to find that log button on my calculator. So here it is. And I'm trying to solve for the log of 1,000. And I get a result of 3. So the log of 1,000 is equal to 3. Now, it seems like we started with a pretty complicated statement, and we got a pretty nice answer as a result. Okay, let's try the next one. So we're looking at the log of 100,000. So log of 100,000. And I get a result of 5. Now again, we started off with a pretty messy looking expression, and we got a pretty nice result at the end. And now if we think about how this answer may have come about, okay, we're going to be looking at logarithms in this lesson. The way this actually works is, in a logarithm, there's an imaginary base down here, and the base is actually a base of 10. Like that for both of them. And what I'm trying to solve for in the logarithm is what exponent on a base of 10 will give me an answer of 1,000. Or in other words, 10 to what exponent will give me an answer of 1,000. Okay, and I know that that exponent is 3, and that's how we got an answer of 3 here. Now let's see if that works for the other one. Again, I'm trying to figure out 10 to what exponent will give me an answer of 100,000. And so I know that that exponent would be 5. 10 to the exponent 5 would give you an answer of 100,000. So that's how that actually works.